All right, welcome back. We are COMP301 in the summer 2020 semester, and it's week 4, part 1 of our broadcast. We're starting Bash shell scripting slow. I laugh again. I know, because when we talk about Bash shell scripting and I say the word slow, you're going to be like, no, you're not. You're not slow. You're right. But we'll try and be as slow as we can today. How about that? So what I was just saying, just before we started recording, is I want to talk about our VM a little bit more. So if I click on settings a little bit, I just want to tell you what I did. So under system, I've allocated more memory, a lot more memory. I have 32 gigs on my system. I put half of my memory onto the system this time. I wanted to see a performance boost by doing that, or realize a performance boost. That's why I did it. And I don't need anything for now, but anything like intensive, especially from a processing perspective, I'd like to have a little bit more memory than 4. I only had 4 in there. 8 would probably be okay, way more than normal. Processor, I've also allocated 6 CPUs. So I have a 6-core CPU, i9, right? So I have that many cores, and I've allocated half the threads to this virtual machine now. So now, hopefully this will be okay, and we're not going to get too many slowdowns on broadcasting. I still have 6 cores left, right, and half of my RAM, so it should be okay when I'm running. Display-wise, I've pumped up the video memory all the way to the right, so 128 megs. I found that this was a little better. I've also enabled 3D acceleration as well. Okay, so those are the things that I've done. And that's really, for the most part, what I did. I think I also changed under General, under Advanced, I also changed the sharing the clipboard and drag and drop bidirectionally. So I can drag from my virtual machine to my Windows machine and back. I wanted to try and do that because I found that sometimes I want to copy paste something, and I couldn't do that with the settings that I had here before. So that's under General, tab, Advanced. Okay? And now that I have that, now I'll start it off. And that should work okay. If you notice a slowdown, guys, please let me know. And what I'll do is I'll reconfigure it by, just, I don't know, lowering some of the specs. You shouldn't have a problem with this. But please let me know. All right. So first things first. Any problems other than, I know a couple of people said there's no problems. Any other problems with assignment 2 that we didn't deal with? You couldn't copy paste. Okay. So Petra, let's meet afterwards and we'll talk about your assignment 2. Assignment 1. I'll be okay. All right, so I'm logging in here like normal. The timing, yeah, I know. All right, a couple things I've done here. I've removed the background. Your computer's crazy slow. Yeah, I know. I've removed the background because I found that it was a little bit annoying. Unfortunately, you can't do that so easily in this version of Fedora 32. So if I go to display settings as an example, then typically under background you'd have another setting in here to change the background to instead of a picture to something solid. In this version of Nautilus file manager for GNOME, it doesn't have, for the settings, it doesn't really have that option, so you have to change it in another way, and I'll explain how to do that in a short bit. Okay, so that's one thing I did. I just removed it because I felt that it was a little bit annoying to have one of these backgrounds there. Okay, and also I wanted to differentiate my background from the background that I used for the other user. I have a fake user that I'm using, and that's why I kind of changed the background too. So we know this is me, this light blue, and then the other user has that other background. Okay. So again, what I'm going to do is I'm going to bring up Terminal. Just for a second. I'm going to get to the PowerPoint in one sec, but first I'm going to pull up Terminal, and as an example, you can see that I can pull up the last settings that I used, even though that I logged off And these are the settings that you can try. So, for example, this one takes away the picture. So I'm just going to drag and drop this into chat. So copy it. Let's see if it works. Okay, try that again. That sucks. Hold on a second. Copy. And let's see if I can put it in chat for you guys. Try putting this in, please. If you copy this into your virtual machine, what it's going to do is it's going to remove the image from the background. Now, if you like the image, you can always put it back, right? But I like to remove the image because it's a little bit more load in terms of the way it works. And for people who have a slower machine, removing the background will help. Okay, that's number one. The other thing that you want to try and do is you can change the background color. So I changed the background color to this blue color, but you can make it black. I'm just going to give you the black color, the hexadecimal code, and you can change it to whatever color you want by putting in a different hexadecimal code in here. So I'm going to copy this thing. I did it again. Hold on. Can't use Control-C. Hold on a second. Copy, and then this is the next one. All right, so try those two. If yours is black already, that's awesome. That's fantastic. But if for those of you who have a problem and they want to make their desktop black, like for example, if I wanted to do that, and I can just paste and then press enter, and you'll notice that my desktop goes black, right? And if I like to try different colors, I have some examples here. This is the blue color that I used before, 6699CC. You can choose another blue color or whatever color you feel comfortable with on your desktop. I think it's just better. Typically, we wouldn't have to do these settings. And if you do a man of G settings, right, then it'll say that it's the G settings configuration tool. And what you can do is you can change a range of things on your system, okay? And this is usually for your graphic settings or your user interface settings. So that's what I've done. I've kind of G settings and I put set, and then the background in reverse order. It's reverse domain name order. So org.gnome.desktop.background, and then I change the primary color value property to whatever I want. Okay, so that's kind of how it works. And I looked that up. That was a quick look up. I was like annoyed. I was like, wait a minute, how come for whatever reason when I look online I see in all the examples that I can go through and change the solid color, but then when I looked at Fedora 32, which is the one we're using, it doesn't have that yet. So it's because we're looking at the bleeding edge. If we used Fedora 31, probably it would work, but not Fedora 32. So that's one thing. I'm also going to, when we talk Bash scripting, Bash is the most common terminal, right? Shell, if you will, that you can use. And we're going to talk about a couple things that I'd like you to start thinking about when it comes to Bash shell scripting. But let's take a look first at the PowerPoint. So where are we? Back to this. So we're sitting at week 4. We're supposed to talk about Linux environment. We've already done this. We've already done this. We've already done this. We've already done this. And I accomplished what I wanted to, which is I wanted to start Bash scripting early because I know it takes a couple of weeks to digest. It just does. And your assignment 2, which is going to be due in a couple weeks from now, week 6, as an example, and this is the last week we're going to do Linux on week 6, it would be too late for me to give it to you in week 5 and have the assignment due the week after. So I wanted to give it to you now and give you the assignment 2 weeks from now, right, to get it done. So that's how it's going to work out. All right? That's why I kind of wanted to start this earlier than later. And what this will allow us to do is we can explore how to do Bash scripting in a number of ways. I think it's a skill to know how to do shell scripting in general. There's jobs out there that love when students come in and they understand how to do a little shell script. That's awesome. So, you know what? It's a good skill, and I'm really happy to work with you on this semester. Okay. So last week we talked about a bunch of Unix and Linux commands and utilities, like everything from, comparing, a lot of comparing and diffs and greps and all that kind of stuff that really useful commands. And you'll see a lot of the quiz questions this week are to do with those things. Okay. But this week, quiz 3 has been released, so that's going to be doing it again this Friday at midnight. So please, there were a couple people who didn't finish it. For whatever reason you forgot or whatever, you forget your quiz, that's 3% gone out the window. Please don't do that. Assignment 2 is also going to be released on Thursday, which is what I'm planning to do, and we're going to start Bash, Shell, and script programming this week, and we're going to carry it over into next week. So those 2 weeks, and we're going to try and work through everything. What's the difference between PowerShell, command line, Bash, Git Bash? Well, they're different shells, right? It's kind of interesting. It's a good question. So remember that PowerShell is a Windows thing. That's a Windows shell environment. Command line, it can describe a couple things. Command line could be command prompt in Windows. Command line, or CLI, command line interface, could describe any terminal window, right? So that's what command line is. Bash, remember what that is? It stands for something, right? So we're going to go back to that, what Bash scripting is, right? And then Git Bash is just a Bash shell for Git and GitHub. That's what it's for, all right? So born again shell, thank you. It was escaping my head. So the born again shell, which is just a type of most popular shell out there. There's Z shell, C shell, and a bunch of other ones. But the born again shell, Bash, is the most popular one. It's used on Mac and Linux systems, and this is why it's so popular. Okay. So going back to that, that's what we're going to be doing this week. Okay. So let's get to it. So one of the things that we need to figure out when it comes to the default shell, you can set up a different shell if you want under user properties. Now again, this user manager tool is going to be different here in this system. And if you notice, if I tried this out, let's go back to our little, let's pull this away actually. If I go back to our environment and I right click and go to settings, by the way, settings you can go to 3 ways. Here, and then go to here, and then you can bring up settings. That's one way of doing it. You can also get to settings by clicking on this and going to settings. That's one way of doing it too. That's settings, right? And the last way is right clicking and going to settings. Okay, so those are the 3 ways you can go to settings. Okay, and when you go to settings, we want to follow what it says here. So if I go down to users, right? And this is where we want to do user administration. And if you notice, right, and when we go into that, it looks a lot different than what we saw before. So for me to change my defaults for Tom here in settings, by the way, there's also default applications. You can choose default applications for your calendar, for your music, for your video, you know, as an example, for whatever. You can choose all this stuff. Default for the web, for mail. We don't have a mail program yet, but you can do all that here. But if I go to users just for a second, and if I go to unlock, this is very similar to what the Mac allows you to do. So I'm just going to use my password to unlock. And you can see that I don't have that here. I have this editor. I can edit my name, but I really don't have access to do that here, right? So that's not something I can do here. Same thing with Tom Smythe. Tom Smythe, it's not like I could go here and change his shell inside of his system. Doesn't like work like that here in Nautilus. Not that way. Not the way it's being shown here. Notice user properties, right? And again, you would normally go, see where it says user manager tool in Fedora? Which version of Fedora is the question you should ask yourself? Not 32, right? Because this is your user manager right here, right? And again, this is all your most important tools right here, right, from a UI perspective. So even if you scroll down to all these ones that we talked about before, there's your network tools. So you can choose your kind of look and see what your wire connection or VPN, if it's set up. You can set up a VPN, Bluetooth, background notifications, and all this stuff that we normally would be going through. Applications, common applications, and integrations. We can go through there, and a bunch of other ones. Okay. You can see that these are all common applications and how they're used. But if you notice, there's no user manager application the way you would see it before. There isn't. Okay. It's not the same as this. So yeah, setting up the typical shell or whatever is not something that you can do at least not in this version of Fedora. Okay, not like the way it's being done in the book, which is a bit of a bummer, because it would be nice if you can go to users and then switch out their default shell, and that's like their choice of shell. Instead of using Bash, if they can use Z shell or C shell or Z shell, it's whatever. It would be nice if you had it here. You just don't. Okay. Oh yes, sorry, I forgot. I did not put that up on eCentennial. Just a moment. See what happens when you do multiple Zoom links. I'll put that up right here, right now. Sorry about that. Week 4. It still will be there. You can always go zoom back, so it's not a big deal. I apologize for that. There it is. So save, and you should be able to see that on eCentennial. Thank you for that. I appreciate you prompting me. Okay. Again, this is the live thing, but you'll also be able to see it later. Okay, so that's the one thing. So there is no control over the type of shell. And if I was to, again, bring up this and type in terminal, that terminal comes up. If I type in user, right, switch users, this is another way of searching. A graphical user interface for maximum powerful computer algebra system, no. System settings, change systems and user settings here. Mate manager, no. For Linux local users and groups, there really isn't anything here, right? So if I even go here, it's going to take me right back to where it was before. It says system settings. Now, I could install an application that allows me to do that, right? It doesn't mean that you're going to get more features if I was to install system settings. But let's try it anyway. Okay, so I'm going to click install. All I did, again, is under my Explorer. Actually, let's go back. I went to the Windows button, I went to type search, and I typed in user, and on the bottom it says software. There's 5 more. One of them that I don't have is some kind of user settings, add user or remove users. See if it says settings, and what it does is it brings me here. But if I go back to that again, and I go to users, right, or user manager, right? How did I get that again? Then it'll bring up like system settings. So if I go to system settings under tools, this is a tool you can download, system settings, right? Again, it says configuration tools for your computer, and there's more than one, as you just saw. It wasn't just this. So this is system settings, system, and you can see these are all the different ones. Here's the configuration tools for your computer, and there's other ones that are in here as well. Okay, so you can certainly try and download it, and it might give you what you're looking for from a UI perspective. So if I go system settings, again, you're going to get to that funky one, this one here, no screenshot, whereas we had something else earlier. Okay, but it may not help you, is what I'm saying. Even if you were to try and explore and find something that is relatable to what you need, it may not give you exactly what you're looking for anyway. Okay, so that's this. This settings gives you a GNOME settings utility for GNOME desktop. And if I launch it, like literally, it's just going to give me that same thing that we've had before. Yeah, that's all it is. Okay, so settings doesn't do that. So just if you look at the PowerPoint and you see this, you'll be like, wait, where is this thing? It doesn't exist. User manager tool does not exist the way it used to in Fedora, right? So you don't have a chance to change your login shell to bin bash. All right. By the way, bin bash is the default shell. Whenever we do a shell script, we're going to talk about. We're going to use something called shebang and then bin bash to make sure it works properly. Okay. So there's a couple things. One is bash profile, and another thing is bash RC. Okay, let's take a look at those two things first. So again, going back to terminal, here we are. So we'll type in the word terminal. And if I go to ls minus al, you can see that I have a couple of things here. I have a bash profile and I have a bash RC. Okay, bash profile, bash RC. And these are hidden. Anything dot something or another, they're hidden files or folders, right? They're not going to be able to be seen unless you do a full minus A. That's what minus A does. L is the list format, or long, if you will. So we want to be able to look at our bash profile and our bash RC. Bash profile only runs once. So you want to change your default bash or your shell, you change it here in your bash profile, right? If you want something to be activated every single time you make a new terminal window, right, or a bash, you put it inside of your bash RC. That's the appropriate way to do it. So one time is here when you log in, and then this time here it happens when every time you open up a terminal window. Okay, so that's something that we want to look at. And again, these are something that's inside of your I'm in Tom localhost. If I go to pwd, you can see I'm in home Tom, right? And if I go up one and I do that again, you see that it doesn't exist here. It only exists inside of Tom, right? There it is, bash profile. So normally what they do in the book is they say use VI, use Emacs, and all this kind of stuff. I'm not really a fan of either of those two. It's great from a command line perspective if you don't want to use something like VS Code, but we have access to VS Code, so let's just use it. So I'll say code and then dot bash underscore profile. Warning, if you make changes to your bash profile here in VS Code, as an example, you may break something. You may break something. So one thing you notice is that this is the stuff that runs, okay? So here's an example of a script. First of all, right, you have some hashtags. Remember, these hashtags mean comments. That's what they are. And then I can specify environment and startup programs when I log in to Bash for the first time, one time, right? Here I have an example of an if statement, okay? If and then end if. Fi is the end if. And then I have a then statement. If this, then do this. That's what those two things do. Okay, so that is kind of a command. We'll talk about this in a bit. Okay, so that is your bash profile. Let's exit out of there. And let's take a look at one more, which is your bash RC. Now this thing triggers every time you make a new terminal window, or a bash, if you will. So again, code.bash RC. Okay. And you're going to see here, there's going to be other things in here. So there's your bash RC. Normally, I want you to notice one thing, that the top of the file tells you the name of the file. This is very helpful sometimes. In the older editors, you couldn't tell which file you were in because they all look kind of the same. They're all white. Here we have some color coding. And again, it says if, as an example, my global definitions are in bash RC in the etc folder. Sorry, someone's coming online. Shikun, are you doing it on purpose, or do you need something, or is it by accident? All right, I'm going to mute you. All right, so this is the kind of the way you write a script. And one thing to note is, notice that I have a path equals. Well, this is a path variable. So variables, you literally just assign. Anything in quotation marks, right, as an example, are the things that are encapsulated. So any funny characters like $signs and backslashes or forward slashes should all be put inside quotation marks. And I also want you to see something else. Notice that $home slash and then .local/bin : and then $home /bin : and then path. What do all these things mean? Well, the colon is like a separator, right? That's what they are. So it separates different paths that we're adding into our path. So what it does is when you're trying to locate a program like ls as an example, then there's a specific path for where ls, the program ls, is installed. So let's try and find that. So again, if I exit out of here and I go here, and if I type in ls, you can see it works, and it works from almost anywhere, right? If I type the word key which is actually a place that tells us the path of things, right? And if I do man which, you can say, it says shows the full path of shell commands. You can decide, you can find out where the shell commands live inside your system. So path of the shell commands, use which. Okay, so if I was to do something like which and then ls and press enter, you can see that the alias ls is actually ls -- color equals to auto, right? So there's an actual setting you get with ls as well by default, and it tells you where it lives, /user/bin/ls. Let's look there and see what it looks like. So again, /user bin, and you can see that, look, there's a lot of commands here. zgrep, make node, make password, a bunch of stuff, right? You can see that these are all the commands in there. Look, there's ls. And if I was to do a, funny enough, ls, and I want to look for ls minus, so let's do -al ls, then you can see that ls is an executable script, right, by both the user and group, right? So user and group have executable, and so is other. User, group, and other. ls is available across all different groups, right? That's one thing. There's ls. Okay? And it's sitting there right here. We're in the right folder. It's almost like if I couldn't get to a command, and if I wanted to find ls and use ls, I can just go right in here. And I can use a command. Let's say, for example, somehow it was off the path, like it was removed from the path by accident. You can go in here and you can still use it because it's just an executable command. I can just type in ls and make it work, right? So if I did ls, and then if I looked inside a folder, let's say, for example, I want to look inside the /home folder, right? And then it'll show me this. Remember, we did this before, ls/home/tom, right? Then it'll show me that. I can keep going, ls/home/tom/ documents, right, /workspace, and that's the workspace we were working with last day, right? And I can do the same thing. I can space up, and then in before the workspace, I can put in -l for long, so I can see it lengthwise, right? Or I can put in LR, where R is reverse order, so from the bottom up. And I can put in ALR, right, which does give me everything, even hidden files, give me in list format, and reverse the order. So you can do all those things all at once. Okay? So that's kind of, you can do that here in the actual command. Now it's very dangerous because if I wanted to, with super user access, I could delete ls. And if I deleted ls, guess what? Can't do that anymore. I can't look through the, and installing ls is might be a challenge for some of you, right? So please, whatever you do in this folder, when you see, when you're in the user bin folder, this folder here, usr bin, please do not delete anything in here. This would be deadly to do, right? For example, doing something crazy like a rm space *** -rf. Sorry, it's the other way around. rm -rf *** here. That'd be bad. That'd be really bad, right? You don't want to do that. You might as well just junk your VM and start over, right? And that would be a big waste of your time. All right, so I talked about this. So the path is important. These are bash commands, if you think about it. And when we start with shell scripting, we want to be able to do some of the same things that are done here, right? So that's the difference between a bash profile and a bash RC. Bash RC is always run every single time. Okay? So here's something. What if, let's go back to home, right? And again, You can see I'm at home. That the tilde is the shortcut for this, right? And what if I just type bash? Well, what bash does is actually I'm inside another shell. So I've got a shell and I'm inside of another shell. I'm nested inside of another shell. And to show you this, if I go ps-al, you can see that, you know, there's a bash shell, right? And you can see that this is the parent ID. Sorry, this is the process ID, right, of this bash shell. And the parent ID is this one, 4153, okay? Parent ID. So again, if I do ps-e, right, let's take a look at this. Are all the things that I want to look at. And let's go, these are all the processes that are running in the background. So CPU help, you know, different CPUs that are running in the background. And these are all the process IDs in order, right, of all the stuff that's running. Different daemons and different things that are running in the background, as an example. So these are different workers. There's bash 4153, right? And there's another one, 4898. Look at that, 4153 and 4898. They're two bashes, right? So again, if I do ps, you can see I've got two bashes, right? And if you did this, ps-l, you can see that this bash, this one, it's a shell, right? Its process ID is 4898. Its parent ID is 4153. It's inside of another bash shell, right? 4153, its parent ID is 4062, which is probably a higher up process. It's the GNOME terminal. That's 4062. And what you can do is you can kill a process. We didn't talk about this last week, but we'll do it now. So let's do man kill. Kill terminates a process, right? What you want to do is you want to put in the process ID that you want to kill. Again, guys, be very careful with what you kill, right? If you kill a process and it's a integral process for your system, example, right now what we have is the terminal process, which is GNOME terminal at 4062, which is the, like we said, 4062 is the parent ID of the bash shell. If I kill this process 4062, then we can expect instability to happen in the terminal. Let's see if we can do that. So kill 4062. Bye-bye terminal. Are you with me? So it's kind of an important understanding how, you know, the bash works, right? Let's bring that up again. Let's see if we can spark off another terminal session. Right? Here it is. And if I do ps and then ps-l, you can see now we only have one bash, right? Its parent ID is 5077, right? And that's probably the terminal process again. We don't see that because I didn't do ps-e, but you can see that that is the terminal process, probably, right? Okay, and look at this. PS is actually a process that ran and terminated 5232. That's the process ID for this process for PS. Its parent ID is 59194, which is the bash shell that we're sitting in right now. Okay, so you can trace a process this way by looking at its process ID and its parent process ID, if any. Okay. So this is interesting. So if I do bash again and then do ps, now I have two bashes. ps-l shows me two bashes, right? Uber Eats. And then if I do another one, bash, right? And I do ps-l, now I have three bashes. So it's like a bash within a bash within a bash. Why am I showing you this? Because I can quit one bash, right, or exit one bash and into kind of come back out, tunnel up into another one. Okay, how do I prove this to you? So if I do ps, you know, again, -l, you can see I only have a single bash. I type the word bash in, right? I'm in one more level. I'm down in a level, almost like I'm nested. I've got a bash terminal inside of a bash terminal, right? So again, ps minus l, you can see I've got two processes running at the same time, right? Two bash processes. And let's prove it to you by just doing something like this. I'm going to say, let's cd to a different place. So cd will go into the root, right? And we'll do pwd here. There's the root, right? Remember that we're in the root now of the system. If I do an ls, you can see that this is the root of the system. This is bad. Anything being done in here would be a bad thing. Example, you know, rm minus rf star dot star would kill everything in here if you did it with sudo super user access. That would be very, very bad to do. Don't ever do that, and most systems will prevent you from doing it. By the way, I can tell you this, sometimes, for whatever reason, all right, people lose a whole server worth of information this way. It's been terrible. It's not an urban legend. It actually does happen. People do really weird things, and they remember, because usually they use Linux servers to house everything, and then they lose everything. So that's why we make backups and backups of backups and so on. All right, so now you can see that this is, I'm inside, you know, this location here. I'm in the root. That's where I'm at, right? You can see that this is the location of where I'm at. But if I exit, right, I'm not at the root anymore. I'm inside my home directory. Oop. Right? So each bash shell, if you will. So each bash shell can have its own, it's a different process altogether, and it's layered one off the other. One thing you can do with when it comes to scripting is create variables, and we're going to talk about that very soon. And some of the ways you can create variables is literally do something like a equals to 5, right? And then if I want to echo the value of a, right, I can literally just do something like I want to echo, I want to see what the value of a is. Whenever I want to find the value of something, it's $, and whatever the variable is. So echo $a gives me the value of a. If I did it the other way around, if I said echo a, it gives me a. Right? It returns to me what I'm asking it to do. So be careful what you're asking for. If I want the value of something, it's there. However, if I go into another bash script, and here I put in echo $a, well, it's not defined. I don't know what a is actually, right? Similarly, if I make inside of this bash script inside of a bash script, remember we're just down one layer, one level. I'm just pointing this out to you so you understand, right? If I make another variable name, b, if that's equal to 10, right? And if I do echo b, you can see 10 is the value, yeah? But if I exit, and if I go back to the first bash script, the first bash level, which is up there, and if I go echo $b, b doesn't exist. However, if I do echo $a again, well, in this scope, it does exist. So you can see that it exists depending on the bash that you're in. Questions so far? Which one did I kill? I killed the process for the terminal. That's what I killed. So if you want to find the process for the terminal, ps minus l, you can see that the bash itself, this shell, is living inside of, it's being running on process number 5194, and the parent process ID is 5077. If I type the word top, remember what top does? It talks about CPU utilization, all this kind of stuff, whatever, and also tells you things like your process ID as well as other things, right? And if this is the top that, you know, top processes that are eating resources. Look at this GNOME terminal here. This is one of the main ones. And the process ID for the GNOME terminal is 5077, right? 5077. Keep that in mind, that number. So again, if I go back up to this, 5077 then is the terminal process for this GNOME terminal session. So if I kill that, kill 5 by the process ID 5077, then bam, the terminal closes. Okay, so we're gonna have to kill processes. Sometimes our process will get stuck, and that's why I'm showing you how to kill stuff. We need to kill it, and we need to kill it by process number. All right, back to that. So are we clear about variable naming? So variable naming, you can do it like this. If I say a is equal to, equals has to be no spaces. If I say a is equal to, by the way, does a compute? Echo $a. No, once I've killed the terminal session, bash ended, and then now it's dead, right? So it doesn't know anything about a. But if I assign a is equal to, again, 20, let's say, and then I do the same thing, the same command, now a does compute. However, what if I was to do a is equal to, with spaces, 20? Then it's going to say, I don't understand what you're talking about. So when it comes to assigning values, right, to a variable, and we're going to talk about the first shell script, you cannot use any spaces whatsoever. No spaces. A can also be anything you want, and it can change. For example, if I said a is equal to hello world, I can do it here in quotations, right? Hello world. But I can't do it this way. I can't say is equal to hello world. Now it's going to say, okay, a is equal to hello, don't know what world is, right? Notice that there was a problem. It didn't complete, right? If I said, reassign it, if I say a is equal to hello, and if I up arrow, you can see now that it's only equal to hello, not hello world. This is a way we can assign value to a variable, and we can get it back with $sign in front. Are we clear? So it's important because we're going to use this kind of stuff all the time. The other thing we can do is we can add two things together. For example, I can say something like if a is equal to 10, and then b is equal to 20, and then c is equal to, we can put in anything in parentheses, a plus b, right? Then I can say echo a, b, c, and see what we get, right? Notice what I get here, funny enough, right? You think that c is equal to a plus b, but actually what it's giving me back is exactly what I gave it. I gave it a plus b, not the value of a plus b, but the string a plus b, and that's what it's returning back to me. So be careful, that is a common error. So what we can do is we can go back and correct. We can put in a $sign in between or in front of and press enter, and now when we go back and do this, you can see now it says 10 plus 20, right? Which is very interesting. Okay, 10 plus 20. However, if I say something like C is equal to 10 plus 20, and if I did echo C, right, it's going to give me back 10 plus 20. It's not going to calculate and make me give it 30 for me. Okay, I'm just going to point this out to you guys, right? Questions around variable naming and the way kind of some of this stuff works. Let's try it another way. If I said something like C is equal to, let's use curly braces instead, and if I said A plus B with curly braces instead of parentheses, and then I did the value of C, then you're going to see that I have that whole thing coming back at me. Notice the curly braces came back, the parentheses disappeared. Okay, so a couple different things that can happen when it comes to variables. All right. So one thing to note is what we learned last week, which is in order for us to run a script, we need to make it executable, right? And the way we can do that in a script, let's do it one more time from this last work. And again, I'm going to go do this and say, here I am in my path. I can go into my documents, And then let's make a workspace 2. Workspace 2. I'm going to keep workspace going on by itself. There's two workspace, workspace 1 and workspace 2. Let's go into workspace 2. Nothing in there. Let's make one. We're going to use touch to create my script. And instead of calling it my script by itself, let's call it myscript.sh. So what is the .sh? Shell script. That's what it means. And it's a nice way of people knowing that the .sh means you're making a shell script. Just a way of telling people what that is. Okay. Then I can go in there and add it in. So if I go to code myscript.sh, I can open up my script. Remember we did this? What we want to do with every script is the first line that we want to put in there is something called a shebang. So it's hashtag exclamation mark, right? And then bin bash, okay? Bin bash. So what this is basically telling Linux is it's saying, hey, look, most of your bash commands are inside bin bash. That's where they are. The shebang basically says I'm writing a script. Okay. Also, and that should be the exact first line, by the way. This is the exact first line. These two characters are the first two characters of all scripts that you write. That's what it should be. The other thing is that you can also put examples of what this is. You can say myscript.sh, the name of your file. You could do a lot of stuff in here. You can say the name, myscript.sh, the author. This is common practice, right? Me. Oh, if I can type my name today, it would be nice. And so on. We can put in other things, description. If I can really not type today, that would be good. Look at that. Woo! Description, demo script, and then date will be today's date. By the way, you can use a script for that, but let me just put in June 15th, 2020. I can't believe it's June 15th already. And those are all comments that are going to be ignored, and then you can do some of the same stuff we did before. Like, for example, I can echo script started, right? And then it'll just echo that out. That's a little script right there. Now, let's exit after I've written this little script, right? So I'm exiting now, and let's run it. What if I just tried to run myscript.sh? It's going to say myscript.sh, command not found, right? Even though we're in workspace 2 and it's right there. Doesn't know what that is. How about if I tried to run it like normal, /myscript.sh? It's going to say permission denied. Why? Because we haven't given executable permission to my script, right? How about if I tried bash /myscript? Okay, so it says script started. It actually ran. I want to tell you this because you can run the script anyway by using bash. Think about bash as like execute. That's what it's like, right? So you could do it and it would run that little script that we just made, okay? Bash and then my script. If I tried it again, and by the way, if I did a ps minus L, you can see I still only have one bash. I didn't make a new bash this time around. I just executed bash. All right. So if I type exit here, I will leave the terminal. I don't want that. So if in order for me to make it work, notice that my script.sh does not have executable. I could change mode or schmod, whatever you want. I could change mode of my script and I can just say +X. If I just did this, +X, everything is +X. And if I did a -AL again, you can see now that my script is green. it's executable across all user, group, and other permissions. Okay? So now if I was to run it, it would run like we expect. And what if I just ran it like this? It would say, I don't know what that is. I don't know what my script.sh is. All right? So we're going to make it so it's executable. But the first thing that we do is we say, hey, you know, this is where we want to kind of execute my script. And we want to run bash in order for us to do that. Okay? So, so now that our script is executable, we can do lots of stuff with it, and we'll be modifying it momentarily. So again, shell variables, temporary store variables in memory for use by the shell script. The symbolic name consists of letters, numbers, or characters. Right? It references the contents of a variable, often reflects a variable's purpose or contents. You want to keep it contextual is what this is saying, just like any other variable that you've ever made. Different kinds of logic structures that you can use in shell scripting. Again, we'll be going over those this week and next week, right? So here's some example of high-level languages. In COBOL, COBOL is super wordy. Add 1 to counter. That's literally like how you code in COBOL. I remember coding in COBOL many, many years ago. Here's another one. Counter is equal to counter plus 1, C++, or counter plus equals to 1. That's another way of doing it. You add 1 to counter, right? How do you do it, though, with a script? Can I do it? Remember, we did this before. Can I do counter is equal to counter plus 1, do you think? Let's see. What do you guys, first of all, before I do it, what do you guys think? Is it possible the way we know how to do it so far? The way it's written there. Cobalt, yeah, cobalt. Cobalt. No, not cobalt. Cobalt is like a creature in D&D. COBOL is a programming language, an archaic programming language still being used by the banks today, unfortunately. All right, so let's go back and try this out. So if I say like, okay, echo $A, it's worth 10. Echo, you know, oops, wrong one. $B, that's worth 20. And I want to add 1 to B. How do I do that? Can I do, you know, B is equal to B plus 1? Or do I want to say the value of B is equal to the value of B, you know, plus 1? Can I do that? And it's going to say, meh, I don't understand what you mean. Like literally, it doesn't understand what you're talking about, right? If I said something like B is equal to the value of B plus 1, okay, and then if I said echo B, now you can see it's 20 plus 1, because what it does is it makes a copy of 20, and then it concatenates it with 1 to produce a value. It doesn't do what you want to do. This doesn't work. Okay, not the way you think. Okay, we're going to get back to this. So again, so we talked about must be, you know, identified as an executable file. You can do this. You go plus X, which is user group other plus X, or just simply plus X, which is what I did, right? You can enter the name. The path must be set. If you proceeded with a /, it's this path, because there's always a dot that kind of executes that particular script. Okay. And one thing it knows is, one thing I have to say is that it's in interpreted language, which means that any script we run, it doesn't run as fast as a compiled program, because it's not compiled, it's interpreted by the bash shell. That's important to understand. Kind of like running JavaScript, kind of, because also JavaScript is an interpreted language, as opposed to a language that's compiled, right? But it is quite different. JavaScript is really improved by leaps and bounds. So that is part of it, okay? Sometimes what we do is we create a little script with a shell and shell scripting, and then we want to do something that we want this thing to do, and then we actually, once we know that this is what the effect we want, it runs a little slower than normal. We go to the administrator and we get permission, and then we run a little C++ program to do the same thing. Okay? So that's kind of the workflow that it's talking about here. So here's some examples, and I'm just going to pull this up so you guys can see it a little better. Again, just like I said, script name, whatever it's called, by who it is, date, purpose, programmer is working on blah, 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 consists of whatever it's doing, and then it has the command. Here's the command right here. So cut minus D is an option, and then this colon minus F4 project pipe into sort, pipe it into unique, minus C, pipe it into awk, and then you want to print this stuff. That's what basically you're saying. All right, and then $2, $1. It actually, that's a linear interpolation, or sorry, that's interpolation, when we're interpolating or injecting stuff inside of the %s. Okay, and then we're going to pipe that into pnum, and then it says cut program number, pipe output to sort to remove duplicates, and get count for program projects, output file with program number followed by count. And that's what this little thing does. That's what the actual script is, this part. Okay, so that's kind of an example of a script. One thing that they're missing here is the shebang, which I think is really important. Okay. So they talk about comments here. I'm not going to go over that again. And they also talk about different kinds of shells. So Linux shells. So born in corn shells, Bash. There's CSH and TCSH and ZSH. I really do like the ZSH shell, to be honest with you, on Mac. It looks really, really nice. It gives you a bunch of different options. Bash isn't terrible either. Okay, and we talked about different kind of variables. One thing is that there's a difference between configuration variables and environment variables and script variables. They're all different things, or shell variables. So one thing we can do is we can run a command to kind of view, kind of all the different environment variables that are running. On different operating systems, it runs differently. So typically what we do is we could run an env command, and the env command, or environment command, basically shows you all the environment variables and how they're loaded, right? So here's an example of that. These are all the different environment variables, and you can see that there's quite a few, right? Take a look. Some of them are literally just aliases for other things, like shell is bin bash, that's where it is. Session manager, as an example, color term, and so on. All right, I'm not going to go through all of them, but you can see that that's what it does. So you can see things like my log name. That's a variable that's been assigned a value when I logged in, right? The desktop session is called GNOME, and so on. And then the language is English Canada. UTF-8 is a character set. And there's a bunch of colors that it defines, as well as other settings that we can go through ad nauseum. Okay, users Tom, and so on. But you can see that these are a lot of things here, some of it that you don't want to touch or mess with. You can fix it. It's not like you can't fix it. It just, there's a lot of presets. Path is a big one, the path. Right, so if I want to print the path, then path is a variable. So if I was to clear the screen and just type in echo the value of path, then I can get the whole path. This is what's on the path. And normally what happens is the path variable, and for those of us who just came from JavaScript, right, remember we went to environment variables and I looked at the path? This is the Linux equivalent, which means that if I go to home tom.local/bin, that is part of the path. So anything I put in there gets added to the path, right? That's part of the path, right? So if I go into .local/bin, let's take a look there. So cd/home/tom/.local/bin, and it says no such file directory. Let's go to .local, and then there's share. right? So it looks inside each of these places, right? Let's try it again. cd/home/tom/bin. Notice bin. It always ends with bin, but I can't get there. So if I go cd/home/tom and then do it ls, right? These are all the things that, this is where it looks here. It looks in here too, right, for different commands, okay, as an example. Okay, cool. So it looks in, and again, if I go back, let's go to that directory. So, okay, USR local bin, USR local sbin, USR bin, USR sbin. All these places are the places where path will search to find a command if it can't find something. So, I mean, it makes sense then that in home tom, if I put something in that, then it should be able to execute, yeah? And let's see where we are right now. Right, we're in home tom. If I go into documents and into workspace 2, and if I copy my script.sh, right, to home tom, right, there it is, right? Well, let's go into something else. Let's go into like downloads, right? So you can clearly see that myscript.sh is not here. But if I do something like myscript.sh, does it run? No, it doesn't, right? Now, even though it looks inside that folder, right, inside of home tom, it looks at home tom bin. Home tom bin. Do you see bin in here somewhere? Nope. However, again, I could run it just like we did before. I can go to, I know the folder. So if I went to run it right from where it was, I can go into, so right now we're in downloads. I need to be in home tom to run that thing. So I would do something like /myscript.sh, and if I did it properly, it'll say script started. So as long as I get the right pathing, I'm good to go. Okay, one step at a time. Let's also remove that. We don't want to pollute this area. Back to here. Yeah? So that's our little script. Doesn't do much right now, but we know how to activate it so far. Okay. So that's the environment configuration. We talked about this, and we can get to that also by using printEnv to view a list of your current environment and configuration variables. Since I did env, but you can also use printEnv. Let's try that out. So if I go to clear and then printEnv, you can see again, I have all those wonderful variables, just like I did before when I pressed env, E-N-V. Okay. And it talks about each of these things in detail, right? So it identifies the path name to the user's home directory system, right? Log name holds the account info of the user currently logged in. Log name, PPID, refers to the parent ID of the shell, right? So parent process ID, that's what it is, right? And so on. Path holds the list of path names for direction, for directories. Search for executable commands, right? And it says redefinable. You can add something to the path, right? All right, and so on. You can see if you read through this, it tells you different things about some of these things that you can set up for yourself, right? We've used some of these before. PWD gives you the path that we're currently on, and so on. So that's like holds the name of the directory that is currently accessed, right? Okay, and then term contains the name of the terminal type in use by bash shell. Let's try that one out. So if I go term, does it work? No. But if I go term it says xterm 256 color. That is what it is. So if I type in echo term, you can see that that will print out because term is actually a the actual name of the variable, right? So these are all variables. They're environment variables. Okay. And by the way, if I make another one, let's say for example I make a new variable called Tom, right? Tom is equal to Tom, right? Tom. And if I go env, do I see Tom in here? Right? Do I see it? I mean, I added Tom, it's capitals. How come I don't see it? Well, because it's not an environment variable, right? These are special variables that are held for the system to use. Okay. Certainly if I type in Tom again, echo $Tom, just because it's caps doesn't mean it's going to be something that's going to be held in the environment. Alright, so that's that part. It talks about shell variables. We already talked about some of this. To assign a variable that must contain spaces, enclose it in quotations, double quotes and single quotes. To reference a variable, use a $sign in front of it, and or enclose it in a curly brace. So let's try the other way around. So if I said echo Tom, you can see it doesn't do what it's supposed to do, right? I want it to print out Tom, the value of Tom, but actually it's not. It's showing me Tom. It's actually printing out what it's doing. So again, be careful. Some of this documentation, it bugs me when I see this kind of stuff. Enclose it in this. Use square brackets to refer to a specific value in an array. Okay, no problem. Well, that means that if I had a Tom array, so if I said Tom 0 is equal to, well, there's no spaces, is equal to hello, and then Tom 1 is equal to world, and then I want it to show Tom 0 and Tom 1, then I can say echo. If I said echo Tom like that, like the value of Tom, you can see that it just says hello because Tom points to the first one, Tom 0, by default, right? However, if I say something like echo Tom 0 and then $Tom 1, you can see now I'm going to get this, hello 0 and hello 1, right? Isn't that funny? Even though we put in world for hello. And if I did the other way around, if I said echo Tom 1, I get hello 1, right? Hello with square brackets around it, right? So it's interesting the way it works. How about the command let? You know, it says let, and it says expression expected, man let. You can see it says it's general commands manual. All right, this is very interesting. Kill, let, local, logout, right? Set, right? There's set, unset, right? Those are interesting commands. Set and unset, echo. Those are all bash commands. These are all the commands that we would use. Also, one of them that we're going to see learn about is export. What export allows us to do is it'll export that variable into other bash commands, so nested bash commands. So example would be if I said something like this. If I said so echo Tom, and you can see that's what it is. But if I go to another bash, I'm inside of another bash script inside of this bash shell, sorry, and if I did echo Tom again, you get nothing. However, if I go up one, so exit, and I go back to the previous bash shell, the one on the outside, and if I said something like export Tom, damn it, right? And if I did bash, and then if I said, okay, now tell me what the value of Tom is. So if I said echo Tom, now I've got this, right? But if I go up one and then go echo Tom, export Tom, like this, export Tom, bash, and then I'm going to find Tom again, echo Tom. Now I'm good, right? So you can export. Using the export keyword allows you to export from your bash script outside of your current environment, outside of your current shell to other shells, right? And what about if I exit and exit again and come back in? So if I do again Alt F1 and start typing terminal and go in there and say something like, okay, give me the value of Tom. Does it retain that value? No, it doesn't. As soon as the bash closes, it's finito. You can't use 0, 1? Let's try it. Let's try 0, 1, right? So if I said, okay, so Tom 0, let's redo it, and then we'll say that equals to hello, and then Tom 1, and that's equal to world, right? And if I went to echo Tom, 2 Toms, Tom 1, if I did echo Tom 1, I get 1, right? Isn't that weird? Echo Tom 1. But if I go echo Tom, right? Or echo Tom 0, I get this. Echo Tom and then comma 0, because comma was what I put in there, right? And then plus square brackets. If I try doing the same thing, if I said something like what you said, which is echo Tom 0 and 1, let's make no spaces, then you're going to see hello 0, 1, right? 0, 1 is the extra stuff that I'm adding, right? Tom is actually a value, hello, comma, right? So it's funny the way it works. I'm just we're trying different things out so you get a sense of how variables work in scripting. So read only, if I want to make a read only, I can use read only and whatever the name is. Let's try that out. So if I said something like, if I put the read only word in there, it says declare -r, right? Declare -ar, and then these are all the different things. It tells you there's something these are all the things that are read only, right? So let's say, for example, I said something like, I want to make Tom read only. So read only, right? Tom is equal to hello, right? And then if I said, okay, well, show me Tom. So echo Tom. But if I try assigning Tom again, Tom is equal to world. And it says Tom is read only. Okay. So that's interesting. If you use enable allows you to do a lot of other things. Enable alias, enable bind, enable break, caller, complete, executable, exit, all kinds of other stuff. You can enable things, and you can disable stuff, right? With enable and disable. Just trying to think of other things I can tell you before. Before I don't want to go crazy today and give you too much to do. To be honest, I know I said that last time, but I really don't today. So here's an example. This is kind of the same thing we talked about before. List is equal to ls or $ls. Now this is interesting. All right, so defining operators. Let's try this out. So if I said something like, first of all, list does not compute, right? Doesn't work. But if I said list is equal to ls, and then I said list, right? Well, list does not compute. I don't know what that means, right? It's not a command that's found, right? If I said echo list, you can see list is equal to ls, right? Just like it says here, right? List name Becky ls or ls. Let's try ls in single quotes. So list is equal to ls. List, same thing. It's going to do the same thing. But if I do echo $list ls, right? So that's interesting that you can do that. Same thing with list is equal to $ls, right? Then what is list? So echo list, right? Well, that's interesting, isn't it? So that kind of executes the command. It actually makes it so that it does a list, right? Dead letter and so on. That kind of executes the command list, right? When I do that. And the same thing goes when I do the other thing. If I said something like bash list, right? No go, right? If I said, for example, list is equal to ls, and then I say something like bash list no go / list, no, can't do it that way because list is not a directory. Doesn't make any sense. Even with my alias, doesn't work. Okay, so just notice what we did. We made it work by doing this, and only when, if and when, that we did the $, the value of ls command. So let's try that again. So if I said process is equal to the $, of ps, and then I said process by itself, no go. If I said echo though process, then you're going to see process, right? Echo $ process, that's the value of, and now it's going to show me ps command. Okay, so very interesting. It's just something that you want to see. So also you can't execute two values at once. That's not true. There are ways of doing more than one thing at once. So here's an example of some more examples. So display contents of a variable with an evaluation, the evaluating operator, which is the $. So that's the value of the variable. Okay, so arithmetic and relational operators. All right, so you can see that there's minus and plus, unary and minus, unary and plus. Plus and minus is addition and subtraction. X plus y returns x plus y. Be careful about this. We showed you that this is not the case, right? Or is it? So example, they did let. This is the first time we've seen let again. X is equal to a number. Well, let's try that out. Remember, there's let and set. So if I said let C, and again is equal to the value of A plus the value of B, and then remember that operand expected error token is plus. Okay, operand expected error token is plus. So okay, well that's interesting because that's kind of what they did here, no? X is equal to blah blah blah, right? So let's try this exact thing. So we can say that let x, capital X, equal 6 plus 4 times 2. These are actual values, right? So if I did that, if I said something like let C is equal to 6 plus 4, right? And then I would echo the value of C. You can see there it calculates. So in actual values, no problem, right? Okay. That's interesting. So let's see. When we did the $, though, we did the $A and $B, it broke, right? So what about if we did the same thing? If I said let C is equal to $A, and it says no, don't know what that means. Error, the token is equals, does certain things, and it won't allow you to add things together as an example when you use that thing. So let to set the contents of a shell variable. That's what we're doing. Let. Okay, and it shows that in kind of example, right? So let y is equal to x plus 4. Let's try that out. So again, we can say that what is C? So again, if we go up a couple steps to echo C, we can see C has still 10. And if I said let Z is equal to the value of C, just like it shows us here. And funny enough, notice that there isn't a dollar sign here. And this is interesting because we've been seeing dollar signs everywhere else. So if I said let Z is equal to C plus 1, and then I said echo Z, now it's 11. So that's definitely a way of incrementing C. What about if we did it the other way around? If I said let C is equal to A plus B, when I use the let keyword, does this make a difference? So then if I go echo C, then you can see that, well, it's 0, right? Well, let's see how that is. A plus B. What is A? So echo A. Well, A is nothing now. Okay, that's why. How about echo B? Oh. Also nothing. So let's say B, okay, A is equal to 10, B is equal to 20, right? Let C is equal to A plus B, and then echo C, 30. And that's interesting. That's the only time where you see that kind of situation. Whereas every other time when we want to press a value, if I just said echo B, you're going to get B back. But if I go, the only time I get the value is if I go echo B, then I get the value of B. Right? But when it comes to let, this is where we can attach things. If I said C is equal to A plus B, well now, remember we did this last time? Echo C, it's just A plus B. But if I did something like let C, right, and that's equal to the value of A plus B, then if I did C, we're getting 30 again. Yeah, again, these are just ways of learning how to code and learning how to make, kind of some simple arithmetic with command line and the shell. Okay, so interesting stuff. There's differences between doing it this way and doing it this way. This is also valid, and like it says, what happens is it calculates x plus 4 temporarily, and anything that's inside of the brackets is gone forever. You can never get anything back from x plus 4. It only does it once. Okay, it doesn't store it anywhere or anything like that. It's an instantaneous operation. Remember, it's an interpreted value. And then, whatever that is, right, if I put double brackets, so let's try that out. So if I said, C is equal to $, and then 2 brackets, A plus B, let's try that out. Right? And then notice there's a semicolon there. So if I said, let C, right, is equal to $, bracket, bracket, A plus B, bracket, bracket, and if I do echo C, still 30. So that's definitely another way. Both ways are valid, right? Both ways are valid. This way, to me, always doesn't make sense. Whenever I saw this, I was like, and why would I do that? Well, you're going to see why. But when I first learned it, I was like, why? Why not just do it this way? It's syntax, guys. That's why. So, okay, we're getting closer. So that's let. Set is a little different. Again, what it does with no options displays the current listing of bash environment and shell script variables. So this is interesting. So if I go set, right? Then you notice what it does. It went through all these variables. I'm just going to make this a little bigger. Oh, that's not what I wanted. So let's just scroll up here for a second. So you can see these is the value of all kinds of environment variables. That's what we're seeing here. Okay, with the set command. Okay, so that's what set does. And then it's -O. When used with no clobber as the argument, prevents files from being overwritten by the use of the greater than operator. Okay, so don't clobber, you know, that kind of stuff. We did this before. Cat new file into old file, enter, and then if we did a no clobber, once we did this, it wouldn't allow that to happen. It would stop files from allowing them to be overwritten that way. Okay? If this makes sense. All right. So again, you can see that displays command lines as they are executed, -V. So let's try that. Set -V. Set -V. Right. You can see that that's the command prompt, right? And if I do a cd, that's also a command prompt, command, and so on. It's very interesting. It's like a verbose mode. Right, so there's set, and if I go man set, which is very interesting, again, it's one of the bash commands that allow you to do different things. And notice it says bash bulletins with a 1. That's like the highest level, the command level for bash, right? So alias with no arguments or with the -P option prints a list of aliases in the form of alias name is equal to value. All right. There's bind and so on. And what we want as we scroll down is set. It's pretty big. You can see that we can keep going for a long time before we get to it. It's quite large, right? We can pipe this into a file if you wanted to read it. Oh, here we go. So it says these are all the different switches for set, right? And then without options, the name and value of each shell variable are displayed in a format that can be reused. -A, each variable or function that is created or modified is given the export attribute and marked for export to the environment of subsequent commands. So that means I can automatically export stuff. -B, report the status of terminated background jobs immediately rather than before the next primary prompt, and so on. I'm not going to go through all of them, but it's quite interesting what you can do with set. -O, and then followed by the different options like that no clobber option, no executable option, no log, and so on. I'm losing my voice, guys. I'm so sorry. I've been talking nonstop for 6 hours. Okay. So that's set. Export, we talked about what export does, right? And it says you must export first before you move to another bash. We did that. And again, the shell looks for programs in the path, right? / is needed if the current path is not, the current directory is not in the path. And to see the directories in your path, right? And then to add the current working directory to the path is path is equal to path : dot. Okay, this is interesting. That what colon does. Okay, so if I was to add the working directory to the path, let's try that out. So if I go into Tom and go into documents, here we are, go into workspace. Okay. And I've got that funny thing now, myscript.sh. So that's the current, like it says, I want to add the current folder, the dot, into the path. I'll do it like this. Path is equal to this, right? So path is equal to the existing path, right? The existing one that I have, right? Plus the current working folder. Okay? So then if I look at path, so echo path, then now you can see that this is the current, what we've got going on. Did it add it in? What does it look like to you? Well, if it did, then if I was to scroll up one, so come up to this, and if I was to run my my script, then it should work, right? But it doesn't. So it doesn't do exactly what it says it's supposed to do. Because again, what we're saying is path is equal to some other path, right? The default path plus something, right? But we should see documents in the path now. And if I go echo path, sorry, it's getting annoying. Echo path, there's no documents in the path. You can see it's clearly not there, all right? Even though it says it is. Add the current working, directory to the path. Path is equal to $path. How about if we use sudo? So if I said sudo path, very dangerous. So again, remember what we're doing. We're saying path without a $sign is equal to $path. We're saying take the existing value of path and assign it to path, right? And then it says sudo. There's a problem with this. It says don't know what you mean, right? To use sudo in this way because you're assigning a variable, and we don't need you to have super user access to do this. Okay, that makes sense. So we're gonna get back to modifying the path in a bit, especially for Fedora. It's slightly different. Wildcard characters, this is interesting. They're known as glob characters. I don't know where they got that from. I was like, glob? Why do they call it the glob? Right? There's no need for it. Right? Glob characters are part of the glob patterns, intended to match file names and words. Special constructions that appear in glob patterns are question mark and star and other kind of characters. Okay? So that's what glob are. Interesting more. Let's try that out. So if I type man more, one thing we didn't cover was this more, which is allows you to page through a lot of data. So for example, let's suppose that we said just type in more, right? More, it says bad usage, right? Because what it really needs for more is file perusal. So -d prompt with press space to continue. So more -d. So let's try that out. Sorry, not really related thing, but more -d. But there's nothing to more because it's not that big. If I did something like, ls -al, not much here, but let's go to a larger folder. So let's /, and I want to do ls -al. See, it's going to take up. Does it go past one? No, in this case it doesn't. Let's just move it so that it's smaller, like this. And let's try that out. So if I said ls -al, and I want to pipe this into more -d, then you can see that I get press any key to continue, right? So what I did there was the pipe character said, okay, I want to take this output and pipe it into another command. So I'll go from one command to the other command with that particular option, right? More being almost like a paging, the ability for us to page from one file to the other. However, if I had lots of room like this, like my terminal window was much bigger, and I tried the same command, right? So I did this, you can see that it has no effect because there's nothing to do more on unless we had, something to space through, which we didn't. Okay, so that's what more does. But here again, like what it's showing is I want to go from chapter 1 to 3 if there's some kind of thing like that. That's the pattern, right? I want to look for a pattern, and then I want to press enter. It's going to look through all of those as a pattern. Okay, I think I want to pause here because I know I'm getting a little bit tired, and I'm sure you guys are getting tired watching me go through each command. And there's a lot more, as you can see. This is a PowerPoint that's going to take at least a couple days, and we're going to do some shell scripting finally with it that actually allows us to do stuff. So I want you guys to absorb this stuff. On Thursday when we get together, I'm going to give you assignment 2. Assignment 2 is all around shell scripting, right? So this is why we are going so slow with this one, because shell scripting, it's a little bit of art and science, and you need to know what you're doing. You need to practice, you need to troubleshoot and try and understand what's happening. And part of it is understanding the syntax, okay, and how it works. So now that we know some things, right, if I go back to my home directory, and let's just exit for a second and come back. Sorry, it's just driving me a little bit crazy. That's what happens when you do, yeah, good. Notice that when I exited and came back, I'm back to my default. So I'm here, and I want to do code myscript.sh. So what if, I'm just putting it out there, now that we know how to add stuff together, what if I said something like, you know, A is equal to 20, and then B is equal to 30, and then C, let C is equal to A plus B. A plus B, sorry, my Visual Studio Code's trying to do some stuff on its own, and then echo $C. I mean, this is in the script now, right? It's not like on the command anymore. Should this work like before? What do you think? So let's take a look at that, and I'm running it. I'm just get rid of this and go to my script by doing /myscript myscript.sh, and you can see that indeed it does calculate those things inside your script. So I think that's what I want to take away from today. You can definitely calculate some stuff inside here, and you know, hold some variables in your script, and you can also do other things. Remember, it can hold names, it can hold paths, it can hold a bunch of stuff inside, whatever you want, very simply. And we're going to learn how to loop through things, do if statements, switch case, a bunch of stuff. It's a whole language of its own if you think about it. And once you learn how to do shell scripting, it can really help you when it comes to things like JavaScript, especially if you want to do things like web servers and all that kind of stuff, your own custom servers. You can do a lot of things where a script will trigger upon login. A script will trigger upon different things happening. It can respond. It can be waiting and running in the background while you're doing something else, right? So this is where scripts are kind of neat. All right, any questions before we depart for the day? I know it's pretty harrowing, guys, and I know we're going from one thing to the other, trying a couple things here and there. I'd like you to try them as well. And part of what we're doing here is looking up Bash scripting. So if you ever want a good resource, again, the internet is your friend, right? You can always go something like Bash scripting, right? And there's a ton of resources online. And again, I just went through the first thing. Bash scripting, everything you need to know about Bash shell programming. And if you look down, it talks about how to do stuff and what everything is, step by step. It's a pretty good tutorial. I just looked at one, you know, that you can find, by the way. I've already done this, and notice it does that shebang. And here, instead of you know, user bin env bash, this is the long version of what I was trying to do with bin bash, right? So that's kind of the first line should be this, the shebang or hash bang, right? To declare to the interpreter that this indeed is a script. That's the first thing you should put in. Then some comments, how you use this thing, right? Use command, and then what the command does. Okay, so those are kind of a very simple example of a script. And there are a ton of resources online on how to do this. When you get your assignment, you know, you're going to have to look some stuff up. Some of the stuff I'm going to cover, some things you're going to have to do a little bit of digging on your own to figure out, because that's part of the learning process. Okay, but I'm going to give you as much as I can. all right, in the time that we have. Again, tons and tons of different ways of doing things as well. Stop it. People are just pinging me on Slack and on Discord. Who knows? Even though they know I'm doing stuff. So again, any questions before we go? Guys, thank you so much for being patient with me. You know, I know that it's a long process, and it's a little bit like watching paint peel, watching somebody code, especially this stuff. It's not as exciting as, you know, the instantaneous gratification of JavaScript or C++ or C#. It's not like that. This is a different kind of feeling that you get when you're coding in the Bash environment. Okay. I know it's a lot to go over. All right. So if we can get the people who weren't able to hand in their assignment stay back for the last 10 minutes, I'd like to kind of go through some stuff with them. Okay. Otherwise, guys, thank you so much, and I'll see you next time. I'll see you on Thursday. I'm going to stop recording now.